Alright, so someone raise your hand and share one thing you wrote. Lily.
The area for a square or rectangle is length times width.
Okay, what else? What else did we write? Delilah.
Parameters when you add all the sides around.
You said what?
Parameters when you add all the sides around the shape.
Okay, what else, Kylie?
The area for a triangle is length times width divided by 2.
Okay, what else? Zoe. You said area is it inside of a 2D shape?
Whatever uses instead of a triangle for height.
Just a triangle or any shape that's slanted. So whenever you use the slanted side of a shape for what?
For height.
What else? What?
Always add the measurements. Always add the measurement at the end, like 20 inches.
Oh, the unit.
Yeah.
Okay. What else do we add to our answer when we're finding the area, or the area of a shape? What do we add, Kaya? Yes. Alright, what else? What about irregular shapes? Let's talk about that for a minute. How do we find the area of an irregular shape? Yeah, well,
Just cut it into 2 shapes and add to your.
always 2 or just cut it into shapes that you, okay. Alright, anything else? No? That's okay. I'll give you a minute to add anything that you may want to add from here that you might not have in your, brain dump now. We are in the middle of class, baby. You should have done that before. Thumbs up when you're ready. All right. Go ahead, you can close your notebook for now. We're gonna watch 2 videos, just again, refreshing our minds on,
sides are equal, and I haven't gone in depth into angles yet, but these are at right angles to each other.
You should not
I'll
be,
just draw it
William.
like that. That means that if
Why are you
this
even
bottom
sitting at a
side
table?
goes straight left and right,
Sit by
but this
yourself.
left side will go
Now.
straight up and down. That's all the right angle really means. Let's say that the side down here is equal to 8 meters, this side right here. And this is a square. And I were to ask you, what is the area? What is the area of the square? Well, the area is essentially how much space the square takes up, let's say, on your screen right now. So it's essentially a way of measuring how much space something takes up on kind of a two-dimensional surface. A two-dimensional surface would just be this computer screen or your piece of paper if you're also doing this problem. An analogy would be if you had an 8 meter by 8 meter room, how much carpeting would you need? It's kind of the size of the space you need to fill out in 2 dimensions on some type of surface. So the area here is literally how much is this size that you're filling up. It's very easy to figure out for a square. It's literally going to be your base times your height. This is true for any rectangle, but this is a square. Your base and your height are going to be the same number. So it's going to be 8 meters. So your area is going to be 8 meters times 8 meters, which is equal to 8 times 8 is 64. And then your meters times your meters, you have to do the same thing with your units. You get 64 meters squared. Or another way of saying this is 64 square meters. And you might be asking, where are those 64 square meters? Well, you can actually break it out here. Let me draw it a little bit bigger than I originally drew it. Probably should have drawn it this big to begin with. So let's say that's my same square. Let me draw it a little bit. So let me divide it in the middle. Let me say I have divide it again. Divide it again, just like that. I'll probably do it neater, and let me do it one more time. Divide these just like that, and then divide these just like that. There you go. Okay, now the reason why I did this is to show you the dimensions along the base and the height. If you show, we said this is 8 meters, and notice I have 1, 2, 3, 4, 5, 6, 7, 8 meters. And the same thing along the side. 1, 2, 3, 4, 5, 6, 7, 8 meters. So when we're talking about 64 square meters, we're literally counting each of the square meters. A square meter is a two-dimensional measurement. That's 1 meter on each side. That's 1 meter, that's 1 meter. So what I'm shading here in yellow is 1 square meter. And you can imagine just counting the square meters. In each row, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 square meters. And then we have 8 rows, so we're going to have 8 times 8 square meters, or 64 meters squared, which is essentially, if you sat here and just counted each of these, you would count 64 square meters. Now, what happens if I were to ask you the perimeter? The perimeter of my square. The perimeter of my square. The perimeter is the distance you need to go around the square. It's not measuring, for example, how much carpeting you need. It's measuring, for example, if you wanted to put a fence around your carpet, kind of mixing the indoor and outdoor analogies, it would be how much fencing you would need. So it would be the distance around. It would be that distance, plus that distance, plus that distance, plus that distance. Well, we already know this distance right here, at the bottom, we already know this distance is 8 meters. And then we know that the height right here is 8 meters. And it's a square. This distance up here is going to be the same as this distance down here. It's going to be another 8 meters. And then when you go down on the left-hand side, there's going to be another 8 meters. We have 4 sides, 1, 2, 3, 4. Each of them are 8 meters. So you add 8 to itself 4 times. That's the same thing as 8 times 4. You get 36 meters. Now notice, when we measured just the amount of fencing we needed, we ended up with just with meters, just with kind of a one-dimensional measurement. And that's because we're not measuring square meters here. We're not measuring how much area we're taking up. We're measuring a distance to go around. We are taking turns, but you can imagine straightening out this fence, and it would just become one big fence like this, which would have the same length of 36 meters. So that's why we just have a meters there for perimeter. But for area, we got square meters because we're counting these two-dimensional measurements. Now, let's make it a little bit more interesting. What happens if instead of a square, I have a rectangle? I have a rectangle like this. rectangle. Let's say that this side over here is 7 centimeters. And let's say that the height right here, is 4 centimeters. So what is the area of this rectangle going to be? It's going to be 7 times 4 centimeters. 7 centimeters times 4 centimeters. Remember, we could draw 7 rows, right? And each of them is going to have 4 square centimeters. Each of those is square centimeters. So if you were to count them all out, you'd have 7 times 4 square centimeters. It's 4 centimeters. So it's equal to 28 centimeters squared, or squared centimeters. What's the perimeter? What's the perimeter? Well, it's going to be equal to this distance down here, which is 7 centimeters, plus this distance over here, which is 4 centimeters, plus the distance on the top. This is a rectangle. It's going to be the same distance as this one over here. So plus another 7 centimeters. And then you're going to have this distance on the left-hand side. But this distance on the left-hand side is the same as this distance right here. This is also 4 centimeters. So plus another 4 centimeters. And what do you get? You get 7 plus 4, which is 11, and then you have another 7 plus 4. You have 11 plus 11, so you have 22 centimeters. Once again, it's not a square centimeter. Now, let's go away from our rectangle analogy, or our rectangle example, so let's see if we can do the same with triangles. So let's say I have a triangle here. I have a triangle like this. And let's say that this distance right here, actually let me draw it like this. I think this will make it a little bit easier for you to see how this relates to a rectangle. Let me draw it like this. There you go, that's my triangle. And let's say that this distance right here is 7 centimeters, right down there. And let's say that the height of this triangle is 4 centimeters. And I were to ask you, what is the area of the triangle? Area of the triangle. What is the area of the triangle? Well, when we had a rectangle like this, we just multiplied 7 times 4. But what would that give us? That would give us the area of an entire rectangle. If we did 7 times 4, that would give us the area of this entire rectangle. If you imagine extending my triangle up like this. This is a right triangle. This is going straight up and down. This is going straight left and right on the bottom right here. Okay? It's a 90-degree angle if you've been exposed to the idea of angles already. So you can almost view it as it's half of this rectangle. And not really almost, it is. Because if you just double this guy, you can imagine if you flip this triangle over, you get the same triangle, but it's just upside down and flipped over. So if you think about when you multiply 7 times 4, you're getting the area of this entire rectangle. You're getting the area of that entire rectangle, which we just did up here. But we want to know the area of the triangle. We want to know just this area right here. You can see hopefully from this drawing that the area of this triangle is exactly half of the area of the entire rectangle. So the area for a triangle is equal to the base times the height. Now this so far, base times height is the area of a rectangle. So in order to get the area of the triangle, you're going to multiply that times 1/2. So 1/2 base times height. So in our example, it's going to be 1/2 times 7 centimeters times 4 centimeters. We know what 7 times 4 is, or we already know it's 28 centimeters. We did that up there. So this right here is 28 centimeters. And then when we want centimeters, and we want to multiply that by 1/2. So it's going to be 14 centimeters, just like that. So the area of this triangle is exactly half of the area of that rectangle. Now, the perimeter of this triangle becomes a little bit more complicated, because figuring out this distance, figuring out that distance right there, isn't the easiest thing in the world. Well, it will be easy for you once you get exposed to the Pythagorean theorem. But I'm going to skip that right now. I'm going to leave that for the Pythagorean theorem video. Let me just give you one more area of a triangle. Let's say I have a triangle that looks like this. This was a very special case.
Alright, so again, just to review on finding area of a triangle, rectangle, and a square. Those are the basic ones you need to know. Everything else can be cut, split, whatever. Now, take a look at this paper that I just passed out to you. You will notice there's a box, or a table if you want to call it, that has rectangle, square, parallelogram, triangle, trapezoid, and then composite figure or irregular shape. This is a cheat sheet for you. So this needs to get glued into your notebook. You'll also notice that it's got surface area and volume, so we're going to be coming back to that. Once you glue this in, you need to open up your iPads. You need to go to question number 21. And once you get there, stand up, and that lets me know you're ready to go. Alright. Says, what is the area of the pentagon shown below? So what is important in this question? What's important in the question? Aiden. Okay, so area. And then what else is important in the question? Camden? Pentagon. Alright, now I have a question. Do we know the formula to find the area of a pentagon? We do not. Do we have a strategy that will help us solve this problem though? Yes, we do. So let's start with the easy one, and let's go ahead and find our triangle. Alright, what is the formula to find the area of a triangle? William?
Length times height divided by 2.
So either one of those. So do we have our base and our height, our length, and our width for our triangle? Alright, so we are going to do 9 times 3 equals what? 9 times 3 equals what, Delilah? 27. And then 27 divided by 2 is going to give me what? What is 27 divided by 2? Mikael? 13 and a half. Alright, so that is the easy one. Now, the trapezoid. You can make this a square, or I'm sorry, you can make this a rectangle and do 9 times 6, get that, then you have to subtract those triangles from the side though. Or, if you want to get comfortable with the formula for a trapezoid, it is base 1 plus base 2 divided by 2 times the height, which seems like a lot. But base 1 and base 2. So base 1 is here, and base 2 is there. So what do we have to do with those two numbers using that formula? Ronnie?
Add them.
What?
Add them.
Add 'em? So we're going to do 9 plus 6, which gives us what? It's 9 plus 6. Lily?
9 plus 6 is 7, no, 15.
15. Okay? Alright, then we are going to divide 15 divided by 2. That gives us what? What is half of 15? Camden? 7 and a half. And then I'm multiplying 7 and a half by what? My height. What is my height, and how do I know it's my height? What's my height, and how do I know? Emma? What's the height, and how do you know? It's on the side, and it's also got these dotted lines right here, right? So whenever you see dotted lines, it's telling us it's the height. So what is 7 and a half times 6? Kylie? 45. So this is 45 feet squared, and this one was 13 and a half feet squared. Do you see either one of those choices as an answer?
No, but
We don't see 45, we don't see 13 and a half. So what have we done wrong? What have we done wrong? Troy? Say it a little bit louder.
We haven't added 13 and a half plus 45.
Right. So you have to do 45 plus 13 and a half, and then you get your answer. We know it's not going to be 27, we know it's not going to be under 17, because neither one of those have a decimal in them. All right, so which one is it? B or C? Levi?
B.
It is B. All right, go to number 28. Alright, so it says, Ashley drew a triangle LMN on the grid below. What is the area of triangle LMN? So what is important in our question? What's important in our question? What's important in that question? Okay, so what is the area of the triangle LMN? And knowing that it's a triangle, right? That's important. All right, so let's figure out how we get our base and our height, our length, and our width. Because do you see any numbers? There are no numbers, so we know we have to have numbers in order to be able to solve this problem. Noah, how do I find my numbers for my base or my width? Okay, so this is technically our bottom, or our base, right? And then what do you do with that?
I would count it, and then I would go from there to the L, and then.
Hold on, so just the base, right? And you would count, so what would you count? The squares, so you're gonna count 1, 2, 3, 4, 5, 6. So your base is 6. And you guys can do this on your iPad. Like, obviously I want your math work in your notebook, but I'm not gonna make you draw all this in your notebooks. All right, now how do we find the height or the length?
I would count from N to L,
From here to here?
yeah. But
Do we-
like, I would draw a line, that way it's even, like, I would make the L go down to N and then 9,
Like this?
yeah,
Okay. Can we also go from here to here?
yeah.
Okay, so either one is the same. So whichever one you decide that you like better. Alright, so now keep going, tell me what you would do now.
Count the boxes,
Okay.
L to N.
6, 7, 8, 9. So yeah, 9 here. Alright, so we know that our formula is length times width divided by 2, or base times height divided by 2. So we have 9 times 6. Raise your hand and tell me what is 9 times 6? 9 times 6. Levi?
54.
Okay. Is that my answer? Huh?
No.
But do you see that as an answer choice?
Yes.
Why do you think they did that?
Trying to trick us.
Trying to trick you, right? Alright, so 54 is not our answer because why, Levi? What do we have to do?
Divided.
To divide it by
2.
2. So when you divide 54 divided by 2, what do you get? Mikhail? 27. That is your answer. Alright, go to section 5 and go to number 2. Section 5, number 2. Right. Alright, go ahead and start solving, number 2. Make sure you annotate it. Make sure you read the question very carefully and answer what it's asking, not what you think it's asking. Alright, so it says the points on the coordinate plane represent 3 vertices of a rectangle. Rectangle is very important. Why? Why is rectangle very, very important to us? What does it tell us about our shape? Noah? Opposite sides are equal. It says, what is the perimeter? Is it asking for area? No, it's asking for the perimeter. So how do we go about finding the perimeter? What can we do? Cristiano? Okay. Okay, so let's start with that. So we're gonna find the length of both sides. So 1, 2, 3, 4, 5, 6. So this side is 6. 1, 2, 3, 4, 5, 6, 7. So this side is 7. Alright, so I did that. 6 and 7. Now what did you tell me to do? Speak up, baby, I can't hear you. Alright, so you can do 6 times 2, which gives us 12, and 7 times 2, which gives us 14, which gives us 26. You can also do 6 plus 7 equals 13. 13 times 2 equals 26. What's another way we can solve this? What's another way? Camden?
6 plus 6 plus 7 plus 7.
Alright, so multiple different ways to solve this problem. There's no right, well there's a right way, but there's no like specific, you gotta do it this way. What you need to understand though is what? What do you need to understand? Are you finding area or perimeter? Perimeter. So if you get confused when you find area, you're doing 6 times 7, right? Which is 42. Is 42 an answer choice? Yes, it is. Why did they put it on there? To trick you. Alright, the correct answer for this one is C. Yes.
I feel I'm gonna throw up, man.
Yeah, go. Just take your garbage can with you. Just don't throw up on anybody, please. Alright, go to number 4. Alright, number 4 says, what is the area of the triangle below? Alright, and I zoomed in a little bit just so it's a little bit easier to see. So, how do we find, well, what's the formula for it? The area of a triangle? What's the formula that we use? Kylie? Alright, what do we have to do here in order to solve this problem? Because we don't have any numbers. So what do we have to do? Zoe, what do you have to do in order to be able to solve this problem?
You have to draw a line through like this.
So from here to here? And why is that important? Right, so that gives us our height or our width, right? Alright, so from the tip to the base, you make a perpendicular line. We know that that is going to represent our height. We have 1, 2, 3, 4, 5. So this is 5. How do I find my base? What do I have to do to find my base? Leo, what do I have to do to find the base? Is it similar to what Zoe told us with having to possibly count? Do we have any magical numbers on there that are going to give us our base? Huh? We do? No. So then how do we find our base? You have to count. Y'all have got to pay attention. So this is 10. So now I'm gonna take those two numbers. I'm gonna do 5 times 10, which gives me what? 5 times 10, Zoe? 50. Is that my answer? Why not? What do I have to do? Olivia?
You have to divide by 2.
To divide by 2. So 50 divided by 2. Whoa, 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 whoa. So 50 divided by 2 gives me 25. That is my answer. All right, last one. Number 5. So this question says, what is the area of a rectangle with vertices at -5, 1, 3, 1, -5, -4, -3, I'm sorry, 3, -4. What's important in this question? Kaylee, what's important in the question? Why are they important?
Because they tell us.
Tells us how many points of the shape.
The distance between them.
Okay, so it's gonna tell us the distance between them. Alright, what else is important? Okay, and then what else is important? Area of a rectangle. Alright, so it's important because it is telling you what type of shape it is, right? So, you all are solving this one on your own. I want you to solve it. And then when you have your answer. You guys need to go to the bathroom? really close to being done. Alright. Get your iPads to the side. Now, this is where absolute value is a beautiful thing if you remember it. Because if you look at these two dots, do you see a number that is the same in both of them? Yes, you do. 1. So you're not using 1, but you're finding the absolute value of -5 and 3. So what's the absolute value of -5? 5. And then the absolute value of 3. Ronnie? Nope. Absolute value can never be a negative.
Oh.
Just a 3. So the distance from, let me make it a little bit more realistic. So if you graphed -5, 1, it'd be about there. And then if you graphed 3, 1, it'd be about there. So the distance from here to here is 8. That's the same thing as finding the absolute values. Alright, then I'm going to look at -5, -4, and then 3, -4. Sorry, I totally looked at the wrong ones. Just kidding. I need to look at the dot that's going to go down here. So which one is going to go down there? Because it's a rectangle, right? And what do I need to find the area of a rectangle? The length times the width. So I have my length or my width. So now I have to find the dot that's going to go down here. So is it going to be 3, -4? Or is it going to be -5, -4? -5, -4. So -5, -4 would be about there. So I'm using this one. And this one. Alright, and I'm finding the absolute value of 1 and -4. So what's the absolute value of 1? It's going to be 1. And then what's the absolute value of -4? Kaya? 4. So what is 1 plus 4? Christiana? And then what do you do with 8 and 5? Multiply it. And you get what? What do you get?
40.
And that is your answer. Is that the only way? Absolutely not. You can essentially do where you find, okay, the distance from this point to 0 is 5. The distance from 0 to this point is 3. The distance from 1 to 0 is 1, and the distance from 0 to -4 is 4. Add those up, get the same thing. What I don't want to see you doing, and I know obviously we don't have graph paper, but I do not want to see you wasting your time drawing 842 lines. That's never going to work, y'all. You will waste so much time. I'd rather you guess than do that. Okay? All right. Today, we're moving into area and perimeter. So just like yesterday, you have your option to work on whatever you want. If you want a hard copy of these task cards, I have them. Okay, sometimes we like to be able to like look at the paper rather than see it on our iPads. You're picking one of those. If you want to do the area and perimeter letters of your name activity, I also have that piece of paper. You are going to need this piece for that. Okay? I don't care what you do, but you're picking an activity to get started on. You need to get your paper out that has your station things on it. If you need more lined paper, it's up here. I don't think you need graph paper today. Good. Alright, go ahead and get started. You are not working as a group or partners, you're just independently working. You may work around the room. You may stay in your seat, you may move to another table. It does not matter to me. What matters to me is that you are quietly working.